Free quiz for parallel, series, and parallel. All right. So, Kirchhoff's junction rule. Here's what this says. At a junction, the current in equals the current out. Okay? So you're gonna take a quiz after this. So current in equals current out. Okay? Example of this is this. The current of 1 going in at this junction, this would be a junction, equals the current going out. Okay, what goes in must come out. That is the junction rule. Okay, good with that. So this is going in, these two are going out. Example of that. Okay. So this is a extension of the law of conservation of charge. So you can't create or destroy a certain charge. It's all there. You could think about this in terms of water flowing. Okay, like water comes in, it's got to go out. Okay. Kirchhoff's loop rule says this: the voltage gain is equal to the voltage drop for a single loop. Okay, so talking about here is if we have a battery, then we had a resistor and a resistor. Let's say the voltage is 12 volts across here, and there's 7-volt drop across this one. There needs to be a 5-volt drop across that one. Okay, the voltage gain for a single loop has to equal the sum of the voltage drops. That's Kirchhoff's loop rule. Okay. This is a extension of the law of the conservation of energy. Okay. So energy can't be created or destroyed. It's all conserved. Gained, lost. Versus. Okay, so how do you describe resistors wired in series? They're wired along a single path, as you saw in the lab. Okay. How do you describe the amount of, or like, what's the mathematical relationship for current in a series circuit? Based upon your exploration, you found that the current at each spot is equal, like you did A, and then B, and then C, and then H. Okay, the current at every spot is equal to all other spots in the circuit. Okay, good with that? It's in series. All the current is the same. So it's an application of the junction rule. Because there are no junctions, the in, the out, it's just all the same at every spot. Okay. The equation for voltage gain, how does that compare to voltage drop across all the resistors in series? The total voltage gain is equal to the sum of the voltage drops. Okay, so if this was 12 volts, or let's say you have 6 volts or something, you have 3-volt drop, 1-volt drop, 2-volt drop. These all have to add up. Okay, so voltage gain is your total equals the sum of the voltage drops. Okay, so this is a direct application of Kirchhoff's loop rule. Voltage gain equals the sum of voltage drops. Okay, and the Equation for the equivalent or total resistance in a series circuit is just the sum of all the resistors. Just add them all up. This means as you add more resistors in series, then the total resistance increases. Parallel. How do we describe resistors in parallel? Resistors are independently wired to the power supply with their own circuit. A circuit in which the current has more than one path to flow would be another way to describe that. Okay, so here we see that current can go this way or it could go this way. So this one's independently hooked up. If you pull this one out, it's not going to affect these. They're independently hooked up to the power supply. Okay. How does the voltage gain across the battery mathematically compare to the voltage drop across the resistors? They're equal. So if this was, let's say, 12 volts here across this, that means there'd be a 12-volt drop across this. That is because each one of these are independently hooked up to the power supply. And so in this loop rule, voltage gain equals the voltage drop for that loop. If you looked at a different loop, the voltage gain equals voltage drop. They're independently hooked up, so they all have the same voltage. Okay. Then the mathematical relationship that describes the current in parallel. This is the total current coming out of the battery equals the current, the sum of the currents through each one of those. So let's say this was 4 amps going through here, and 1 amp going through this one, and 5 amps going through this one. The total current coming out of the battery would be equal to 10 amps. Total current coming out is equal to the sum of the currents going through. Okay. And the total resistance, equivalent resistance, is 1 over the total resistance is equal to 1 over R1 plus 1 over R2 plus 1 over R3, so on and so forth. And we'll talk about what that means in class.